Now we're on section 1.4, measurements. In this section, we're going to explain the process of measurement, identify the three basic parts of a quantity, describe the properties and units of length, mass, volume, density, temperature, and time, and perform basic unit calculations and conversions in the metric and other unit systems. So measurements provide us the information that is the basis of most of our hypotheses, theories, and laws in chemistry. They give us different types of information: the size and magnitude of the measurement, which is a number, a standard of comparison for the measurement, which is a unit, and an indication of the uncertainty of the measurement. So without units, a number can be meaningless or confusing. What if your friend told you to get to your house, it takes her 5? 5 what? 5 minutes? 5 hours? Or if I were to tell you that, I live 30 away from Barstow. 30 what? 30 miles? But it's also California. In California, we measure distance and time when it comes to drive. So is it 30 minutes? So we need units. We have an updated version of the metric system called the International System of Units, or SI units, that have been used since 1964 in chemistry. So we're going to be friends with the metric system in chemistry. So the base units of the SI system, the base unit or the SI unit of length is called the meter, and it has a symbol of an M. Mass is the kilogram, and it has a symbol of kg. Kilo meaning 1,000, and gram being the base unit, if you will, of the grams. And grams is with a G. But the SI unit is kilogram. Time, the SI unit is seconds, which is abbreviated with an S. Temperature is Kelvin, with a capital K. Electrical current is amperes, with an A. Amount of substance is the mole, which the symbol is MOL. Don't get me started on how lazy chemists are. We can't even add a damn E to mole. And luminous intensity is the candela, and its symbol is the CD. In general, we're going to be focusing on these top 4 and the mole in this class. So we can put prefixes and symbols in front of some of our base names to change the actual amount in that unit. So, for instance, deci, deci has a D, and it decreases our number by 10 to the negative 1. So a decimeter is 1/10 of a meter. A centi is 10 to the negative 2, milli negative 3, micro negative 6, nano negative 9, and so on and so forth, up to femto, 10 to the negative 15. So each of these prefixes have a specific symbol that also goes with them that can go in front of the symbol for our base unit. We also have prefixes to increase the amount of our units. For instance, kilo means 1,000. So the SI unit for mass is the kilogram. And I know it seems kind of confusing because everything else doesn't have that prefix. So the gram, even though it's on the SI unit, is our base unit for mass. So you put a K in front of it, and now you have 1,000, or 10 to the third power grams. You put an M in front of it, now you have a megagram, giga and tera, etc. And these can go for any of our units. You could have a megameter or a terasecond. It doesn't matter. It matters depending on what you're measuring, but these prefixes are good for all of our units in the metric system. So now let's start talking about the individual types of units. The SI unit of length is the meter. And this was originally intended to be 1/10,000,000th of the distance from the North Pole to the equator. And now it's defined as the distance light travels in a vacuum in 1 over about 300 millionth of a second. Yeah, it doesn't really matter. A meter is about 3 inches longer than a yard. So these are not to scale, these aren't actual size, but these are showing some relative comparisons of a meter, a yard, a centimeter, and an inch. So mass, the SI unit of mass is the kilogram, which was originally defined as the mass of a liter of water. Now it is actually defined by a cylinder of platinum iridium alloy kept in France. And it's about 2.2 pounds, 1 kilogram. So this is a replica prototype kilogram at the National Institute of Standards and Technology, aka NIST. Notice it's like super kept under vacuum and like sealed twice because you don't want any air to mess with it. It's exactly 1 kilogram. So there's actually technically 2 kilogram references in the world. Now temperature. The SI unit of temperature is the Kelvin. We do not say degrees Kelvin. We don't put a degree sign either. It's just Kelvin. Degrees Celsius are also used in the SI system. Okay, and we can interconvert between Celsius and Kelvin very easily. If you want your temperature in Kelvin and you know Celsius, it's your temperature in Celsius plus 273.15. So there's no such thing as 0 Kelvin. As a matter of fact, 0 Kelvin is called absolute zero. It's never been achieved, that we've gotten close, but it's basically where all molecular movement completely stops. So Kelvin doesn't have any negative temperatures, whereas Celsius does. With time, our SI unit is the second. And we can add prefixes to do larger or smaller time intervals. Sometimes hours, days, and years are also used. Now, there are such things as derived units from our base units. One of those is called volume, and this is the amount of space that something occupies. So the standard SI unit is a cubic meter. I don't know why that didn't. Superscript. Okay. And the way that we get this is when you measure, for instance, let's say we have a cube. I know I suck at art, but we measure its length, its width, and height. Okay, each one in meters. And to find the volume of this, it's length times width times height. And our units can be multiplied and divided. So we have meters times meter times meter. So we get cubic meters. Now we also use liter and milliliters for volume. 1 cubic centimeter is the same as 1 milliliter, and 1 cubic decimeter is the same as 1 liter. So oftentimes milliliters and cubic centimeters are used interchangeably. So here's also kind of looking at these relative volumes, so you can see what they look like. So here's this figure A. This big guy here is 1 cubic meter, and then it goes down to 1 cubic decimeter, which is also a liter, and then we take a little cube of that, and that's 1 cubic centimeter, which is the same as 1 milliliter. Density is another derived unit, and it is the ratio of the mass of a substance to its volume. So mass, we generally in the lab measure mass in grams and volume in milliliters or cubic centimeters. Now the SI unit for density is technically kilogram per cubic meter, so that's the SI mass and SI volume. But in reality, we actually don't really use kilograms per cubic meter. We use grams per cubic centimeter or grams per milliliter. They are the same thing. Okay, so grams per cubic centimeter are often used for solids and liquids. And then we do use grams per liter for gases. So gases take up, you really have to do grams per liter because they're so lightweight that you need to use a larger volume to get enough of a mass to even measure. But again, grams per cubic centimeter, same thing as a gram per milliliter. Cubic centimeters and milliliters are the exact same thing.